This is a lesson on vertical translations of trig functions. So we've already looked at many of the transformations for trig, the stretches, for example, but the vertical translations are a fairly simple type of thing, but you have to be careful because trig graphs are always harder to track than are regular functions. But the key idea is that they behave otherwise exactly the same as everything we've looked at in previous lessons and units, in fact. So let's start off by looking at a few graphs. y1 is equal to sine theta, y2 is equal to sine theta plus 2. Now these are going to get graphed on your calculator. I'm not going to bring them up, but I would remind everyone that when you are graphing these, instead of using theta, use x, just like we always do. And for the second graph, close the bracket around the x before you add 2. And although you could graph these in degree mode, I'm going to stick to rads, which is the conventional way to have them. So make sure your calculator is in rad mode. And also, to set our window for the normal trig graph, we simply go zoom and then down to zoom 7, which is zoom trig. And that'll standardize our window setting from basically 1 pi to the left, or excuse me, 2 pi to the left, 2 pi to the right. Now, what we had done earlier is for difficult graphs where there's some intense, severe horizontal shift or stretches, we would change it manually. And you can always do that following the basic rule of thumb that I gave you. But if you have a graph that hasn't been stretched too much, it's kind of a normal looking thing, you don't have to. Zoom trig will work for most conventional graphs. And if it doesn't, then you can go in and change it. But I'll stick with it. And this is what we'll end up getting for our two graphs. Our original y1 equals sine x or sine theta looks like that, minus the scale not being quite as clean. The second one is sine theta plus 2. And so by inspection we can tell that this is a vertical translation of 2 units upwards, which is what we would have expected, because that plus 2 at the end it would do that. Now I've drawn in a dotted line in the midpoint of the graph. And you want to be clear when you're translating these vertically that every point is going up 2. And the point that we're most interested in, at least for now, is the midpoint. And that is going to be at y is equal to 2, because that should be on the x-axis, but it's been translated 2 units up. So if we went back to this equation, sine theta plus 2, the plus 2, as I mentioned, is a vertical translation of 2 units up, relative to y1 equals sine theta. So no big surprises there. And the graph taken on its own would look like this. So no change to the period, but you will notice that its maximum value is 3 and its minimum value is 1, just by inspection of the graph. This one's a fairly easy one to read. And many of the questions you get with vertical translations have to do with the amplitude and the range. So the amplitude in this case, in all cases really, is from the center of the graph to the top. So the amplitude is still 1. And the equation would give us that information besides. The range, however, although I did give it to you by inspection, is equal, y is going to be greater than or equal to 1, the lower limit is 1, the upper limit is 3, and then all real numbers. So you can recognize that by inspection for most graphs. Unfortunately, not everything is going to be as simple as this particular graph. So we do use a formula. We can use a formula. Anytime you're dealing with a sinusoidal wave, that is a sine b theta plus d, or a cos b theta plus d, where the d is your vertical translation, there is a little formula that will always work it out. So if you need to find the range, and it's getting out of hand on you, we work it out by d minus the absolute value of a for the lower limit, and then the upper limit would be d is plus the absolute value of a, and then y would be all the values in between. This is not provided on any formula sheet, but it is fairly intuitive. And my advice is, although use that if you want, but the inspection of the graph will usually work. You can tell just by looking at the graph what the upper and what the lower limit are. So don't rely overly much on the formulas. So let's do a few graphs, and here we want to sketch them and find the range of the following functions. Now the sketch is optional if you're just looking for the range, but I'm using this opportunity to work on some of our basic graphing methods. Number 1, y is equal to 3 cos theta minus 1. And as always with a graph question, I want to take stock of all the information. The amplitude is equal to 3. The period is 2 pi. We would expect the period to be 2 pi because there is no b value other than 1. So there's no change to the period at all. The vertical translation is 1 unit down. So if we were to graph the untransformed y equal 3 cos theta, it shouldn't say that it's untransformed. It's got that vertical stretch of 3, but it hasn't been translated. Compare that one to y is equal to 3 cos theta minus 1. Predictably, the 3 cos theta minus 1 has just been translated or shifted down 1 unit. The shape is identical, though otherwise. If we just looked at the graph 3 cos theta minus 1, then this is what we get. So on your calculator, had you entered it, of course it's not quite as nice a graph on the calculator screen, but it should be something that resembles this curve. And the amplitude is from the midpoint of the curve all the way to the top. Now you have to either eyeball the midpoint, or you just look back on the graph. The vertical translation was minus 1. So that minus 1 will give you the midpoint right there. So we know we have that. That would be our d value equal to negative 1. Now the range. I'm going to use, even though I just finished saying don't rely over much on the formula, I will use it for the practice in this case, but you could recognize it by inspection probably more easily. So this would be minus 1 minus 3 for your lower limit. Now that absolute value around the a is only there in case you have like a reflection in the x-axis, in which case you don't care about it because the amplitude is always the positive value anyways. The upper limit would be negative 1 plus 3. So the lower limit is negative 4, the upper limit is 2, and y is going to be between those. And that matches what we saw on the graph. So, or by inspection of the graph. Number 2, y is equal to negative 1/3 sine 2 theta minus 1/2. A little bit more complicated. Take stock of everything that's happening. The amplitude is 1/3. Remember that the amplitude is always just the positive. It's the distance from the center to the top, to the crest. So the negative does give us that reflection in the x-axis, but it doesn't really affect the amplitude. The period, this one forces us to analyze the period. We do have a b value of 2. So as always, the period is 2 pi divided by that b value. So 2 pi divided by 2. That will simplify to just pi. Considering we're using our calculator, we don't even need all this information, but I will remind you that when you're graphing these or working with them, the quarter is a very useful measure. And the quarter, therefore, would be the period divided by 4, so pi over 4. And when we actually look at our graph, I'm going to make sure that that's the way it should be, that it matches. Our vertical translation is down 1/2 unit. Not very good English on that, but down 1/2. And there is this reflection in the x-axis. It's the negative in front. So on our calculator, I won't bring up the calculator for this one, but you just enter it as it is, negative 1 divided by 3 sine 2x, close those brackets, minus 1 divided by 2. If you want, you can go 1 divided by 3 in brackets, and it would give you the same figure. I would still keep it as zoom 7. You're probably already there. Shouldn't make any difference. Because we are having a period change for this one, we may find that it's nicer to change it, but it really isn't going to make any difference. And then when you graph it, you should get a little graph looking like this, minus the dotted line, and of course the scale won't be quite as nice. That dotted line, though, represents the d value, the vertical translation, so you can see that it is at -1/2. Interestingly, we have no x-intercepts, but our x scale is perfect, right? The pi/4 does represent the quarters if you take a look at it. The bottom of the graph, the trough, the first one is at pi/4, midpoint pi/2, crest at 3 pi/4, and then back where we started from at pi. Now to get the range, we will have to either eyeball this one, which is a little tough to deal with, or else use that formula. And I'll use the formula. D minus the absolute value of A for your lower limit, D plus absolute value of A for the upper limit. So therefore, -1/2, the d value, minus 1/3. So notice I didn't go minus -1/3. I just took the absolute value of that A. And then the upper limit would be -1/2 plus 1/3. Do the math on it. Get a common denominator or just use your calculator. Your lower limit will be -5/6. Your upper limit will be -1/6. That is a test question. Just getting the range, but for one that's not that easy to deal with.